Having covered the features of a parabola in class, we are now ready to start sketching parabolas given their equations. But first, remember that a sketch is a diagram that gives a general idea of the required shape. It's not accurate, but it should include the relevant features. So as far as parabolas are concerned, what are the relevant features? We have seen that a parabola is symmetric, so that should show in your sketch. Concavity should be apparent, whether the parabola is concave up or down. The intercepts with the axes, they should be clear. And the vertex, at least the axis of symmetry on which the vertex lies. And if you have the ability to work out the coordinates of the vertex, that will also be a good idea. We'll do this through 6 examples. Each of them will have its own particularity. So let's start by trying to sketch f of x equals negative x squared plus 2x minus 11. First of all, we know that the parabola is concave down because the coefficient of x squared is negative. Furthermore, we know that the y-intercept is 0, negative 11 because this is the value of c. Next, we should check the discriminant. The discriminant is equal to b squared minus 4ac. So b squared is 2 squared minus 4 times a, which is negative 1, times c, which is negative 11. This gives us 4 minus 44, and that's less than 0. So it's apparent now that this parabola does not intersect the x-axis. So we should look for the axis of symmetry. The x-coordinate of the vertex which lies on the axis of symmetry is given by negative b over 2a. And that's negative 2 divided by 2a, which is 2 times negative 1. That's negative 2, and that's 1. So the x-coordinate of the vertex is 1, but what's the y-coordinate of the vertex? We can calculate f of 1, and that gives us negative 1 plus 2 times 1, which is 2, minus 11, and that gives us negative 10. So we are now ready to sketch the parabola. Let's draw the axes first. I don't need the first or second quadrants. I will start by indicating the axis of symmetry. At x equals 1. I know that 0, negative 11 is a point on the parabola, so let's say this is negative 11. I know that 1, negative 10 is the vertex, so let's say we're here. Let's say this is negative 10. And that's all we have to go with. Using a smooth curve, we try to make it as symmetric as possible. Now, drawing on this thing is not very easy, but that's your parabola. You've got the general shape, you've got the coordinates of the vertex, you've got the y-intercept, there are no x-intercepts, and that's it. Let's try another example. Let's consider this. Again, it's very obvious that the parabola is concave up because the coefficient of x squared is positive. Looking at the value of c, we know that the y-intercept is 0, 9. Next, we go to the discriminant to tell us more about this parabola. So the discriminant is b squared, which is 12 squared, minus 4 times a, which is 4, times c, which is 9. And of course, you can go and do this on the calculator, but there are always easy ways out. If you think of this 9 as 3 times 3, and you take one of the 3's and multiply it by this 4, and the other 3 and multiply it by this 4, you'll get 4 times 3, which is 12, times another 12, which is 12 squared. So the discriminant is 12 squared minus 12 squared, and that gives us a 0. So it's obvious that this quadratic is a perfect square. Of course, you could have known that already, but because the discriminant is a perfect square, we can factorize, and we know that the sketch will be a tangent to the x-axis. And since it's a perfect square, we take the square root of the first term, which is 2x, the sine of the second term, and the square root of the third term, and that's squared. Then obviously your x-intercept is at negative 3 over 2, 0. And you have all that you need. You can start sketching. In this case, we don't need the third and the fourth quadrants. Let's indicate our vertex. And this is our negative 3 over 2. And let's say that this is your y-intercept, say 9. The scale isn't perfect because you don't have to have exact scales, and you sketch the parabola, trying to make it as symmetric as possible, but it's not always very easy with thin, elongated parabolas. So it's going to be something like that. This is a horrendous sketch, but then it's very difficult to draw on the vacuum. When you are sketching, you're supposed to put your hand inside the curve to get a smooth curve as much as possible. And this is your parabola, the general shape, the vertex, the y-intercept, the tangent with the x-axis, and the single root or the repeated root. That's it. Let's try another one. Just like we started before, it's concave up because the x squared coefficient is positive and the y-intercept is 0, negative 7. We test for the discriminant, and this is b squared, which is 16, minus 4 times a, which is 2, times negative 7, and this gives us 16 plus 8 times 7 is 56, so this is 72. The discriminant is positive, so there will be two roots. It is not a perfect square, so I wouldn't go for factorizing the quadratic. It's not going to be easily factorizable. So in order to find the coordinates of the vertex, I would test for the vertex at the x coordinate is negative b over 2a, which is negative 1. So what is the y coordinate of the vertex? And that can be found out by calculating f of negative 1. This is 2 times negative 1 squared plus 4 times negative 1 minus 7. And this is 2 minus 4 minus 7, and that is negative 9. So we know the x and y coordinates of the vertex. We know the concavity, the y-axis, the y-intercept, but we still don't know the roots where the curve will cross the x-axis. We can decide to calculate that by the formula, but if not, let's see what we can do. We have our Cartesian plane. At x equals negative 1, we have the axis of symmetry, and the vertex is at negative 1, negative 9. The y-intercept is at negative 7. So we can sketch a parabola more or less like so. Now, what are the two roots? Here and here. If we're happy with this, that might be enough, but if we want to calculate the roots, then don't forget that we have the formula, and you need the formula because you cannot factorize. So the first root will be, let's call it x1, negative b, plus or minus, the first root is a plus, which is this one, the larger root, the square root of 72, which is the discriminant, divided by 2a, which is 4. And the second root, which is the smaller one, will be negative 4 minus root 72 divided by 4. And if you wish, you can simplify either of those expressions, and you know that this is the larger root and this is the smaller root. Let's go to another example. In this case, we have this quadratic. It's obviously concave up for reasons mentioned above. The y-intercept is 0, negative 5, and testing for the discriminant gives us b squared is 9 squared minus 4 times a times c, and this yields 81 minus plus, this is 10 times 4 is 40, which is 121, which is 11 squared. So the discriminant is a perfect square. Therefore, since it's a perfect square, the expression can be factorized. Furthermore, since it's positive, there will be two solutions. And of course, if you can factorize it into two linear factors, there will be two solutions. So let's factorize it. We have 2x and x minus 5 plus 1, And if you check, negative 10x plus x gives you the minus 9x, and that's absolutely correct. So this gives you the first root, x equals negative a half, and x equals 5. So where does the vertex lie? Now you have a choice. You can either do negative b over 2a, or you can simply take the x coordinate, which is halfway between the two roots. And halfway between 5 and negative a half, the vertex is at 5 minus a half, which is 0.5, divided by 2. That's 4.5 divided by 2, which is 2.25. And if you would like to work in fractions, this is 9 over 4. Now, what is the y-coordinate of the vertex? It is possible to take the 2.25 and substitute it into this quadratic, but then the calculations will turn up to be messy. You can also take 9 over 4 and work in simple fractions and substitute it in this quadratic. Again, the work will probably be messy. I suggest taking either of those two and substituting it in the factorized form. What I'm going to do is take the 9 over 4. So the y-coordinate of the vertex is f of 9 over 4, and this equals 2 times 9 over 4 is 9 over 2 plus 1 times x minus 5, you substitute 9 over 4 minus 5. And mentally, the 1 is 2 over 2, so this is 11 over 2, times the 5 is 20 over 4, 9 minus 20 is negative 11 over 4, and this gives us negative 121 over 8. And then you want to work this out. This would be minus 15 and 1/8, which is 0.125. Now we're ready to sketch. We have two roots. The first root is negative a half. The second is at 5. Halfway in between, more or less. This is 2.25. The y-coordinate of the vertex is at negative 15. So let's indicate that. Negative 15.125. And the y-intercept is at 0, negative 5, so it's somewhere here. And if we sketch, that's our parabola. This next example is very easy. because it's already factorized, so we already know that there are two roots. We know that it's concave up. We know that the two roots are at x equals -1, x equals 5. The y-intercept can be obtained by substituting x equals 0. And at x equals 0, this is 2 times 0 plus 1, which is 1. 0 minus 5 is -5. So the y-intercept is at -10. Now, where is the vertex? Simply take halfway between the two roots. The vertex is at 5 minus 1 over 2. 4 over 2 is 2. And the y-coordinate of the vertex is f of 2. Don't expand, just substitute in the brackets. 2 times 2 plus 1 times 2 minus 5. This is 2 times 3 times -3, which is -18. And we are ready to sketch. -1, 5, and your axis of symmetry is in the middle between the two, more or less. The y-intercept is at -10. The coordinate of the vertex is further down, and you pass here and here. So this is going to be a thin parabola, but here we go. Obviously on a piece of paper it'll be nicer looking, but because it's already factorized, it's easier to work out. And our last example is also factorized, but it's concave down. The roots are 4 and -3. The y-intercept is when x equals 0. This is -2 times -4 times 3. And this gives us 24. The x-coordinate of the vertex is halfway between the two roots. So 4 minus 3 over 2 is a half. And the y-coordinate of the vertex is f of a half. And that's -2 times -3.5 times 3.5. Now we're squaring two numbers. Well, we're squaring a number that ends with a 5. There's an easy way to do that. The sign is now positive. Keep the 2. 3.5 times 3.5. You're going to have the 25. A point, and then 3 times 1 more than the 3. 3 times 4 is 12. So 12.25. This is a shortcut. If you don't like it, you can use the calculator, or you can multiply in any way. So 2 times 12.25 is 24.5. And I'll leave sketching to you.